All right, this is going to be AP Calculus Self-Check 5.2 Solutions. I've assumed that you've already given yourself 8 minutes to do all 4 problems. Let's go through this. And I notice that this is a little bit off. There we go. So here we go. Applying this definite integral to this, this equation, what do we get? And this is going to be the antiderivative. So this is going to be x squared, divide down 1/2 minus x, evaluation bar 0 to 3. All right, so applying 3, or substituting in 3. 3 squared is 9. 1/2 of that is going to be 9/2. And then 9/2 is going to be subtracting 3. So let me do all of this substitution is 9/2, and then I'm going to subtract 3. And I'm going to subtract my second substitution. When I plug in 0, I get 0. Perfect. Too quick. 0. There we go. 9/2 minus 3, getting like denominators, multiplying this by 2 over 2. It's going to be 9/2 minus 6/2. That's 3/2. So the correct answer here is B. If you want to see that, you can write it out. So 9/2 minus 6/2 is equal to 3/2. There we go. All right, number 2. So I have the definite integral of this function. Negatives might trip us up, but I think it's pretty straightforward. So when we do this, we need to just be careful when we do x to the power of, it's going to be not -4, but -2 when I add 1. And then I'm going to divide down, so divide by -2, and that's going to be evaluated between 1 and 2. So what is that going to be? So two things subtracting each other for the substitution. Subbing in 2, what do I get? If I okay, this is the part that can be tricky. I can see why this might be missed now. 2 to the power of -2, that's going to be 1/4. Why is that? Let's take time to analyze what's going on here. So 2 to the power of -2, that's the same thing as 1 over 2 to the power of 2. Remember, negatives just flip it. It changes it so it's from the numerator to the denominator, or from the denominator to the numerator. It just goes back and forth with negative powers, and that's 1/4. So right now I have 1/4 divided by -2, which means I'm doing this times 1 over -2, and that's going to be -1/8. So let me write that in here. I have a -1/8, and now I'm plugging in 1. 1 to the -2 is just 1, and then divided by -2 is -1/2. -1/2, double negative, so when negatives kiss it becomes a positive. So we can go ahead, and I'll do that in a different color to have that in our notes. We're adding, and -1/8 and 1/2 need a like denominator, so I need to multiply this by 4 over 4, and that will turn this problem into a -1/8 plus 4/8, and my final answer is 3/8. And the final answer is D. All right, let's take a look at number 3. This one. So you probably wanted to try U substitution, I'm guessing, but if you didn't, that's actually correct, because if you use U substitution or taxman, you'll notice that you'll get a variable rate. You can't pay the taxman a variable rate, and that's because you need to distribute. Whenever taxman doesn't work, distribute. That's the general rule of thumb. So distribute this square root of x into each of these terms to make this indefinite integral into x to the power of 3/2 plus 2, I'm not going to do square root of x, I'm going to do 2x to the power of 1/2. And if you're not sure how I got these values, go ahead and check Self-Check 5.1 Solutions. I explained it a little bit more there. So this is going to turn into, when I take the antiderivative, it's going to be x to the 5/2, divide down, so 2/5, plus, and it's going to be 2x to the 3/2 multiplied by 2/3, so 2 times 2 here. These are being multiplied, and that is evaluated between, oh, it's not evaluated between, it's just adding c, so plus c. You're always going to be evaluating or adding c, so it's one or the other. It's easy to, okay, I shouldn't say it's easy, but that's a good way to remember. You're always going to do something after you do all of the antiderivatives. So I'm running out of room. Let's go down here. We have, oh, I think we're actually there, looking at some of these solutions. So this is 2/5 x to the 5/2. So 2/5 x to the 5/2. It looks kind of like this, and that is indeed the answer. Yeah, it's D. 4/3. Yeah, all we had to do is multiply to simplify the 4. Perfect. Let's move on to number 4. So this guy, we need to use u substitution because we can't get rid of this fraction. So what should we set u to? And the general rule of thumb here is take whatever is the most complicated. That thing looks more complicated than the numerator. So we will say u is equal to x squared minus 4. That means du, actually, I should stick with u substitution, but you can use taxman here. I'm going to do taxman in a sec. Jump ahead in the video if you want to see taxman. So du is going to be 2x, and therefore, du dx, I always forget that, du dx with respect to whatever this is. And therefore, when we solve for dx, we find that that's equal to du divided by 2x. All right, subbing in what we know. So all of this is going to be used to sub into our equation over here. Not an equation, but our integral over here. So I'm going to still rewrite that x divided by, it's no longer x squared minus 4, it's going to be u. And it's going to be multiplied by dx, but dx is du divided by 2x, so times du divided by 2x. And notice that these x's will cancel. And I'm left with this integral here. I'll just simplify it a little bit, and that's going to be u to the negative 1 dx. All right, so I can take the antiderivative of that, and that is, you might think, oh, it's going to be u to the power of 0, and then divide by 0. You should know whenever that happens, that's not the correct way. That's the special rule. This is the natural logarithm. So now that we're taking the antiderivative, this is going to be the natural log of u. Technically, it should be absolute value, whatever. It's a conversation for another time. You'll notice that in here it's supposed to be absolute value instead of parentheses. And it's just a domain issue. You can't have a negative natural log, so you're just a... Anyway, I'm getting distracted. This is going to turn into, we need a plus c here, of course. This is going to turn into the natural log of u used to be x squared, or the u is x squared minus 4, x squared minus 4 plus c, and that's as far as we can go. So let's see. Oh, we made a mistake. Sorry. You probably caught it already too. If you haven't caught it, find the mistake. Pause me now. All right, so the mistake was right here. I should have divided by 2 right there. Sorry about that. So let's go back and change this to, it's not that hard of a change. You just have to add the 1/2 out in front. 1/2, 1/2. Because remember how you can move a constant. This is a constant of 1/2. You can move the constant outside the integral right here. And that's our final answer. Perfect. So 1/2 natural log of all of that. So there it is, 1/2 natural log of all of that. Correct answer is C. All right, so I promised Taxman. Here's Taxman. So Taxman, oh, it's been a while since I've done this, but you have to first figure out who your taxman is. Oh man, Taxman is your x. No, sorry, you find u first. U is equal to x squared minus 4. X squared minus 4. Taxman is x, and then du is equal to 2x. 2x. So treat that as a fraction, which turns into 1/2. And therefore, my new equation would be, after that, would be the integral of, remember, x was a taxman, so he gets replaced by 1/2. That was the x, and now I need to multiply that by 1 over u. This, what's remaining is the x squared minus 4, which is 1 over u. And that can be a little bit tricky to see. And all of that is still, I guess, du. This is where taxman becomes informal again. And from there, it's the same procedure, really, from all of here. That integral is the same thing as the integral of, or 1/2 the integral of u to the negative 1 du. And the antiderivative of u to the negative 1 is natural log, so you have 1/2 the natural log of u, and you can see, oh, plus c, that's the same thing that we got right here, and then you just do the same final step, 1/2 natural log of x squared minus 4 plus c. And I will add a note here at the very end because we're done with the video and you can stop me right here as I go on my tangent, which is when you go backwards from natural log, the domain of natural log is only positive numbers. For example, if you take out your calculators right now on your phones or with the TI-83 plus, punch in natural log of -1. It'll say something along the lines of error domain or something like that. And that's because the graph of natural log looks kind of like this, where you can't actually have any x coordinate in the negative. So when I'm going backwards, I need to make sure that we don't accidentally get something in here that's negative. So to avoid that, we always say it's the natural log of absolute value of all of this. So x squared minus 4 plus c. Now it's impossible for this to be a negative. It's impossible to give us a domain error. All right, thanks for watching.